Okay, here we go. All right, so we have a couple things that we need to get done today, okay? Our conversation about animation is going to continue. We have two things that we're going to do today. You're going to have some lab time to do a cool little flying saucer slalom. More on that in a minute. And then your homework this week is going to be what I call lovingly Starship Landing. And this is going to continue our exploration of object-level animation inside of Maya. So we're starting off kind of animating objects, and then next week is going to be kind of our first real kind of introduction to character animation. And then on what would be week 5, we jump in with some actual characters. So we're kind of baby stepping our way into this. Learning how to animate inside of Maya requires some energy, okay? And I want to make sure that we don't overload you and short out your circuits before we really get into the heavy stuff, which is the character animation component. So if we look at the stuff that we're going to be looking at today. All right, so here we go, Starship Landing. I gotta apologize, I was banging my head against this right before class was started. I don't know why my thumbnail or my video isn't loading. I think it has everything to do with how I'm hosting it. So I'll see if I can fix that maybe during our lab today. But I've provided you guys with a file here. And for this animation, you're going to be taking a small little model file that I provided you guys, and you're going to be landing it on a platform, okay? And it's going to give us a really great opportunity to talk about arcs, timing, and spacing of our keyframes inside of our timeline a little bit, okay? So there's going to be we're going to revisit many of the principles of animation that we've talked about in GCOM 400 and see how we can apply those principles here inside of the 3D space, because there are some different considerations that we need to keep in mind as we start to flush all this out. On the technical level, we're going to be talking about play blasts today as well, which is going to be a handy-dandy way for you to quickly export and see your animations inside the QuickTime viewer without having to render them. So that's going to come up during the homework in the lab. So the homework is going to be Starship Landing. You're going to be landing a Starship on a platform. We'll talk about that more in a minute when we open up the project file. However, I want to get you guys started and start exploring our lab, which is this flying saucer slalom. Okay, let's actually download the project file real fast. Here it is, down here at the bottom. Well, let's open up the good old Maya, get this party started. Here we go. All right. Last week we talked a little bit about the Dopesheet. This week we're going to continue exploring the Dopesheet in a very direct way. We're also going to start talking about camera blocking today a little bit. When we're making computer animation, we need to be reminded that at the end of the day, we're going to have to put all of our movements in the lens of a camera. And I'm a big believer that we need to put that camera lens on the set, if you will, as quickly as we can. That almost needs to be the leader of our entire decision-making process. Great illustration of this is Pacific Rim. Did you guys see Pacific Rim? Yeah. I haven't had a chance to see the second one. Is the second one pretty good?
I saw part of it. It was pretty good.
Yeah?
I watched on a plane with flight.
Yeah. So if you're not aware of what Pacific Rim is, just think giant robots killing giant aliens. Okay? That's kind of the premise Pacific Rim. Gigantic, huge robots battling these aliens that are invading planet Earth through a magical portal in the middle of the ocean. Yeah. It's actually a pretty good film. I liked it. It was a lot of fun. Okay, one of the big set pieces of the film is a fight between the main character and another big alien in the city of Hong Kong. Right? Now imagine robots that are the size of skyscrapers. Huge robots. Okay? One of the problems that Industrial Light and Magic had, especially during the pre-visualization stage, is understanding the scale of these robots and the scale of a city. Now, if you were just to take a regular city block, let's just say you're down, let's see, one of the biggest intersections here in town. Maybe you're on like Watt and like Folsom. That's a pretty big intersection, right? I think at that point it's like a 6 or an 8 lane intersection going both ways. Big intersection. Now imagine a robot the size of a skyscraper standing in that intersection. Big, right? big. Is that robot going to fit in the intersection? No. It's going to be much bigger than the road is, right? So how can you have this wonderful battle between a giant killer robot and a giant killer alien in downtown Hong Kong and have the scale match, right? Well, shocker, it didn't match, okay? And the scale of all the roads in downtown Hong Kong had to be adjusted to match the scale of the robots, right? They actually had to physically make the streets much wider in the 3D model of Hong Kong to facilitate the placement of all these robots inside of their set, right? This was a discovery that they made when the animators started doing all the camera blocking, and when they found that they didn't have enough room to move around inside the streets of Hong Kong. When you put a lens on it, the buildings and the illusion is going to be compressed a little bit, because that's what lenses do, okay? And they found pretty quickly that they needed to break the reality of Hong Kong and fabricate a new reality that matched the context of the animation, okay? Point being, we need to get a camera lens on our sets pretty quickly, and then we're going to animate to what the camera sees, okay? Because our little viewport here inside of our 3D app is something that we're only going to see inside of Maya. That's fundamentally not what our audience is going to see. So when we're starting to plan out our animations, we need to very carefully and consider what our audience is going to see. Now, at the moment, one of the challenges that we have is this perspective viewport. Now, last week, many of you guys were rendering, and you were just rendering from the perspective view, okay? I have my outliner open here, and I want you to look at the contents of your outliner. If you don't have your outliner open, it's in the Windows tab, or the Windows pull-down menu, okay? If you look inside the outliner, what are the first 4 things? They're cameras, okay? If you're coming from another 3D app, this is a little bit different, right? In Maya, all of the views of our scenes are actually cameras, okay? That we're switching between when we switch our viewports, okay? Well, I want to create a new camera, okay? I want to be able to use the perspective viewport as a work viewport. It's a viewport where I can very quickly start to check out all these different elements from any number of views, and then I want to have a separate camera that's going to be rendered, okay? So here's what I'm going to do. Because I want to be able to lock down my camera and establish the perspective of my scene without kind of getting in the way of my workflow, okay? So I'm going to create a new camera. If you go into the rendering shelf, there it is. Create camera. Okay. They changed the icon on me, and I was like, huh. Okay. Camera 1. I want to hit the F key to fit it inside my viewport, and it's right smack dab at the origin of my scene. And there it is. There's my camera. Okay. Now let's give this a really great name. I just don't like having it be called Camera 1. I'm going to hit the return key to enter the name, and let's just call this R&D Cam. What would you imagine R&D stands for? Render Cam. Okay. If you're working in the context, in the framework of a much larger production, this could be, shot 01, okay, or shot 2. I'm just going to put R&D Cam in there so I know, so that I'm telling everyone in my production crew that this is the render cam. These are work cameras, okay? These are cameras that allow us to view and to animate and to build our scenes. They're not designed to be rendered. We can render them if we want, but ultimately we want to be able to control the context of what's being rendered out in the final frames. We do that with our own camera, with the new camera, okay? So it's in the rendering shelf, and it's this icon right there. Okay. Right here, so you're not seeing it in your viewport? So you can't see it in your viewport? The little camera icon? Hit the W key. It's inside your flying saucer at the moment. If you have it selected in your outliner, yeah. There it is.
Oh, I thought that was part of the saucer.
Okay. So now that we have our render camera inside the scene, the next natural question is, well, how do I look through the camera's viewfinder, right? How do I physically tell the computer to see what that camera sees? Because I want to take what this camera sees and the attributes of this camera and start to define what maybe the characteristics of the shot's going to look like, okay? And then I want to lock that down, okay? I don't want to change it. To look through a camera, there's a couple things that we can do. Here's the easiest way to do it, right? If you go into the panels section, the top of your viewport, not the top of your screen, but the top of your viewport, there's two options, okay? Perspective, and then find your camera. Okay. This is going to change what the panel, what the viewport's showing. Or the other option is right down below it, look through selected. Okay. If you have the camera selected, you can tell the viewport to look through that selected object. I don't believe I have my camera selected in the outliner, so I'm just going to choose render camera from the list. Aha, so now I'm looking through that render camera's viewfinder, okay? So I'm seeing what the camera sees, okay? Maya gives us a really great heads up down here at the bottom. I would really recommend that you pay attention to those badges at the top of the viewport, or excuse me, at the bottom of the viewport. It's going to help you kind of keep your bearings as to what you're looking through in that moment, okay? So we're looking through the boundaries of our render camera, looking through its viewfinder. Life is good. I now can start to do some shot blocking here and compose my shot. But again, the viewport is not necessarily giving us the best representation of what the render is actually going to be. Is your question, Patty? No. Okay, great. I want to be able to see the boundaries of my render frame itself, okay? Because what you see in this viewport isn't necessarily going to be rendered in its entirety, okay? So check it out. I think I talked about it last week in this class, but I want to make sure that it's highlighted because it's really, really important, okay? First and foremost, we need to define our render properties, okay? This is literally the first thing I do whenever I start any animations. I go into my render settings and I start defining this, okay? I need to define the frame size because we're going to animate to that frame size, okay? And we only want to animate once, right? Changing the frame size after we animated is often going to require us to go back in and reanimate sections, which is something that we just don't want to do, okay? This is already so hard. Let's just do it correct the first time. So if you go into the render settings, okay, at the very least, down here at the bottom, change your image size, okay? The default is 960 by 540. Let's do 1280 by 720, okay? This is going to be the resolution for about half the class, okay? Towards the latter parts of the course, then we'll start doing 1080 stuff. Rendering images at 1920 by 1080, it's almost double the size. So one might imagine it's going to take longer to render, and I don't want to have to do that until we're a little bit more comfortable in our entire pipeline, okay? So 1280 by 720, that's the first thing that we want to do, okay? Once we've defined the height and width of our render, then we can return to the viewport and turn on our resolution gate. Oh, since we're here, I apologize. Render cam, okay? I think it was Levi. He said he's on his render for his solar system. He saw Saturn and then it disappeared and turned black.
It depends on this. Like for example, if I use SkyDome,
Mm-hmm.
it appears black, but everything else is not colored.
Interesting. Okay.
But then if I use physical sky, everything appears black and like white, but Saturn disappears.
It may be that alpha channel. Okay.
Oh, maybe.
It may have been that alpha channel getting baked into the image. Okay. We can, in post-production, in After Effects, once we get going with After Effects a little bit, that's a feature that we can turn off for the image sequences that we import in. But we can ask it to just not render an alpha channel. So keep that in mind as well. Okay. So render camera, renderable cameras, render cam. We've changed the width and height to 1280 by 720. Now we're ready to rock and roll. I want to see the boundaries of that resolution inside the viewport, because the resolution of my viewport is far bigger than what's going to be rendered, okay? And that's going to bring us, to the top of the frame, to these buttons in here, Okay, because these all have a very specific role, and it's good that we know it. This first one, this is going to turn the grid on and off. Okay, the grid. Second one, this is film gate. This is not something that we really need to worry about. Okay, however, the next one, this is resolution gate. Okay, and now if you have this guy selected, this will kind of put the boundary, the ghosted boundary on the outside. That's all it's doing. This one turns the resolution gate on and off, and the other one just makes it ghosted from here. Okay. Now we can see quite directly what the viewfinder of our camera is actually picking up. Okay. This is really important to establish very, very, very early on. Okay. Because we need to animate to camera. We're not just animating whatever we want to animate, okay? The audience is only going to see what's rendered, okay? So if we animate something that the camera doesn't see, guess what? They're not going to see that, okay? I know it sounds silly and it's very obvious, but it's something that, in all honesty, we need to point out, okay? The render camera is only, the audience is only going to see what's in front of the render camera, okay? So we need to define that. And we need to, put our render cameras in a spot that that's going to be a whole lot of fun. Now, there's any number of ways that you can do this. I think I'm just going to put the little pylons of my little slalom course at a cool diagonal angle. If you have your camera selected, this is actually kind of neat. So I got my camera selected over here in my outliner. If you open up your attribute editor, which could be found right here in this tab. If it's not in this tab, it's this guy right there. That's our attribute editor. Okay. Okay. So a couple things to point out. Focal length. This is going to be the type of lens that's in front of our camera. Okay. The focal length kind of determines how much of your environment the lens is going to pick up. What you don't see in here is that I wish it said millimeters. Right now it just says 35, and it's assumed that you know it's millimeters. That's how we measure focal lengths in cameras, by millimeters. Okay. The lower that number, the more wide angle our camera is going to be. Right. Like out there in Hollywood, you see every once in a while you see something filmed like a 14 millimeter. Or a 17 millimeter lens. It's pretty wide angle, okay? The background, when it's wide, the background has more of a role inside of our shot. The alternative to that would be something that's more telephoto, or as I hate this is my least favorite word, zoomed in, okay? So something like a focal length of 200 would be more telephoto, okay? When things get more telephoto, the background starts to shrink, and you're going to get what's called compression, where the background feels like it's right on top of the foreground. Okay, so I got my camera selected. Okay. Okay. I'm in the attribute editor. Okay.
Go one more down on the tabs.
I need to be able to see it.
Yeah. See, I made my own without knowing that I didn't see the file.
Oh.
So I have my own made, but
Yep.
it shows the cue. It doesn't show the actual.
Yeah, I see. Okay. Go ahead and stop your animation too. And it may not be updating because your animation was gone. That was it.
Oh, that was it.
That was it.
I didn't know it was going.
Okay. So one of the things that I could do, let's just as an illustration of this, if I was to put this to 200, okay, I've changed the focal length of my camera, and now you can see that it almost feels like our big, gigantic set is really a miniature, right? Everything is so tiny, right? The moment you start increasing the focal length on your camera, we start to strip out the distortion that the lens puts on the image itself. When it's a wide-angle lens, a straight line is going to be kind of bowed, okay? When it's a telephoto lens like this, now all of that image wrapping and image warping has been minimized to a certain degree. So play around with it. This is a great way for us to very quickly. I'm going to put mine at 22. That may be a little too wide. I can noodle with this all day, so I'm going to choose not to. So the question that you have to ask yourself when picking a focal length of your lens is how much of a factor or how much of a role does the environment play in your shot? Okay? If like a shot like this, where the environment is part of the movement, a wide-angle lens makes a lot of sense, right? Because we see more of the environment. It's as if our body is just kind of plunked in this environment and we're seeing it through our audience's eyes, right? If we want to focus our audience on just a character, okay, then having a telephoto lens is going to be a little bit more important because the background is going to be minimized inside the frame. If you ever want to get a really great illustration of this, just go onto YouTube. Just type in focal length comparisons, and there are 1,000 videos that do the exact same thing, right? It's like, you know, a guy or a gal sitting at a desk, and then they change the focal length on the camera, okay? Start and stop, every start and stop, they change the focal length, and you'll see it's the exact same framing, exact same lighting, exact same everything, but the background and the compression that you get between the foreground and the background changes quite dramatically. Okay.
Do we have the same properties in the photography as well?
Say it again?
Do we use the same like in the photography when I'm doing? Yeah.
Oh, same thinking. Yes, please do. Oh, absolutely. In often ways, that's a great way to add value to your kit, to your tool set, is to have a couple different lenses in there. You know, if you're shooting, like for example, if you're doing like a whole bunch of buildings, shooting pictures of buildings for a client, you're going to need a huge wide-angle lens to get as much of that building as you can in one photograph, right? In comparison to if you're doing like portraiture, okay? Then you're going to go to like an 85mm lens or like a 100mm lens that compresses the background and kind of minimizes the role in the background and the context of the frame, and you know it really focuses your audience on the subject, the person, versus the background. I'm a big believer that the focal length for our lenses really has everything to do with the background and not the foreground, okay? So figure out what's important to you. Okay. All right. So let's get to work here a little bit. So I don't want to change the composition of my camera at all. Well, actually I lied. I am going to change the composition of my camera just a little bit. Something maybe yeah. Okay, now I'm being an artist. Darn it. Okay, that's gonna do. That's good enough. I can noodle with this all day. Point being is I want to lock this down. Okay, I'm going to choose a composition, and then I want to lock these properties down to ensure that I don't mess it up. Okay? Far too often our muscle memory takes over, especially as 3D artists, and we assume that this viewport, the render camera viewport, is just like the other perspective viewports, and we just want to jump in and start orbiting and panning. No. I want to lock this down to ensure that this camera's placement inside of our scene does not change. Okay? It's really quite easy to do this. Okay? Here's my suggestion. Okay? I got my render camera selected, and I'm going to go over into my channel box, because the channel box is going to expose all the transformation channels for this object. And I'm simply just going to grab, you can grab all of them. The scale for a camera doesn't matter. And then lock selected. Now, because those channels have been locked down, I'm trying to orbit right now, and I can't do it. So I selected them over here in the channel box. So I grabbed the first one, held down the Shift key, grabbed the last one. Then simply by right-clicking on the channel name itself, I get a contextual menu, and then down there at the bottom is lock selected. That's how I did it. Okay? It's a great way to establish your camera composition and then to turn it off so you don't mess with it on accident. That's often where our problems bubble to the surface. Are you guys hot? So warm in here, is it just me? I'm going to open the door a little bit. Luckily, our cool Arctic weather will cool things down in a hurry. If it gets too cold, especially for the people over here, let me know. I'll close the door. Okay. All right. So we have our render camera established. Okay. Now let's get into the business of animating. So this is where your own personal workflow can modify it a little bit. I'm just going to go into a 4-up view here. And let's see, actually, yeah, on this one right here, this is a 2 view. I'm going to go into the 2 view. This is going to be my standard perspective view. And then this panel here, I want to sync to render cam. And I'm not seeing all of it. There we go. Right here. These are going to change your viewport. I did this one down here. Okay. So this is what I've created. And I like this. This is working pretty well for me. Because whenever I'm animating, I always want to make sure that I have access to what the camera sees at all times, okay? Because what we are fundamentally trying to avoid as computer animators is making it work in here exclusively, okay? We need to make it work in here exclusively, okay? So we're always, always, always going to be rendering to what the render camera sees. Levi, did you have a question?
Yes, I can't move my render cam.
Good.
Can you move your render cam?
No, once you've locked it, it's locked.
Okay, good. No, I was just wondering if that's okay.
Yeah, you have to go back to the channels and unlock it.
Okay, that's fine.
Yeah,
Just wondering.
that's the idea. We want to lock it down so we don't accidentally lock it or move it around. And this is something that you'll see out there in the production world, right? The director may come in and he or she will stand and they'll establish all the camera shots, right? And then they'll lock the cameras down, and then we animators have to animate to what the director has created for us, okay? So it's very, very likely that we're not going to be able to mess with our render camera compositions. All right, so let's get to work. Our job here is to go in and to animate my little flying saucer. Uh-oh, it's going to crash on me. I'm just going to take a nice cleansing breath. Yeah, I fundamentally believe that there's something wrong with my install of Maya on the instructor station. It's going to make it gigantic. Okay. Let's see. Now, here's what I would recommend. Let's go back to your workspaces. Up here at the top. Nope, up where it says workspace. And let's reset current workspace. Okay. There you go. Now you're up and running. Yep. Okay. So, bear with me just for one moment while I get this started again. All right. Okay, so let's get our little flying saucer moving. Okay, a little flying saucer here. There we go. Dun, da, da, da.
Does it matter if it starts from the middle?
Sorry, say again.
Does it matter if it starts from the middle? Those can fit here.
The question is, does it matter if it starts from the middle? Why would you want to start in the middle? Okay, so one of the things that we want to continue to practice in our craft animation is all these principles of animation, right? And one of the principles of animation that we defined in GCOM 400 was the importance of arcs, right? And movement arcs. everything in our world moves on an organic arced path. Nothing, even flying saucers from the year 3085, I don't know why 3085 is made up number, right? Even those creatures need to fly in an arc, okay? Everything needs to move along an arced path. That's actually something that we really want to try our best in defining. Okay, so that's our first mission here, and let's do this. I'm going to see if I can very quickly play catch up. Go. Excuse me, I just play catch up real fast. Go. All right, let's just go with that. Lock my stuff. All right. Yes, go ahead.
So to make if you want to give the camera like a path, you do it just like you would any other object in animation, like just like set it, give it a keyframe, and then set it to a different like destination on other.
You got it. So we're gonna get in there and we're gonna start keyframing some stuff. And I'm not gonna lock my camera. That seems to be where the bug in my computer is. I gotta get the computer services guy to reinstall Maya because this is getting a little insane. Like I said, cleansing breaths. Okay. Actually, I'm not going to do the camera composition stuff because we got to get to animating. Okay. So when we're animating this stuff, we need to start figuring out what the movement's going to be. We have to have a vision for this, right? We just can't. Nothing comes for free in the art of animation. Zero, right? The computer's not going to add anything. There's no magic tool that says make everything look awesome. We have to do everything. So it starts with our imagination. We have to visualize what this entire movement's going to be before we lay down one keyframe, because there's nothing in the computer that's going to help us. We physically put everything in. Okay. So with the idea that we're going to be infusing our animations with all these arcs, maybe I want to take some inspiration from aircraft, things that I've seen out there in the real world. And I think I want to have my little flying saucer come in maybe right in front of camera. Right in front of camera, and then start the slalom course, and then it zips off going towards the rear of my scene. That might be kind of fun, right? And if I'm clever about it, I can do it in a way that looks pretty cool. Okay. All right. So I'm not going to lock down my camera because it seemed to be the thing that was causing this to crash over and over and over again. But I do need to have a camera in that matches the resolution that I'm after. Okay. Okay. Voila. Okay. And then we're going to load that render camera over here. Excuse me for a minute. I'm just having a day. It's that damn Pixar short. Okay. All right. Okay, so let me grab my flying saucer and we'll get to work here. Okay, so now that we have my camera composition established, I can see pretty clearly how far I need to animate the flying saucer to camera. Okay, Once you get it in the lens, the mechanics of animation starts to get a little bit easier because now we physically see and we can physically animate to what the camera is going to record. Okay? I always like to imagine these render cameras as like a little video recorder, and it's just going to capture whatever's inside the viewfinder. So I need to make sure that what I'm creating jives inside that space. So the first thing that we want to do as we go through our practice here is to block out some keyframes. Just because we're using the computer doesn't mean we get to walk away from our animation pipeline. We're still going to establish a whole series of keyframes and then time out those keyframes to ensure that we're getting the illusion that we're after. Okay? Now when an object is moving, when the object is closer to the camera, we need it to be moving a little bit slower. Okay? Another reason why we try to get it into the camera lens as fast as we can, right? To ensure that what we are animating is just being read correctly at frame rate to our audience, okay? So let's start blocking this out. Now I want everything to move along some nice paths here. Now this is the fun part of animating. Like, where do I want it to begin? I think I want it to begin off camera. And then maybe, should I do like a whole Michael Bay thing? I'm going to do a Michael Bay thing. Against my better interest, I'm going to do a Michael Bay thing. What? Where nothing is in focus on the frame. I like it. We just need to have an intervention with Michael Bay, right? Just culturally, we need to say, stop, we love you, but you've gone too far, right?
I think he just knows his target audience.
Maybe he does. Maybe he does. Maybe I'm clearly not that target audience, right? Gonna know your tribe, as they say, right? Gotta know your tribe. All right. So what I'm going to do is not that. I think I'm going to have my little flying saucer start off over here. And let's get to the business of animating. So I'm just going to key this there on frame 1. To make it easier for you guys, I want to change the key tick size, to 3. So you guys in the back can see what's going on. And I'm also going to change the playback speed to honor my frame rate. There we go. All right, so there we go. Frame 1. I'm also going to turn on my auto key, right? I like the auto key. I've already created a keyframe for the position channels for my flying saucer. So anytime I move my flying saucer on a different keyframe, it's going to automatically update, which I like, and automatically key. Now at this point, I'm not trying to establish the timing. Our process is to establish the keyframes first and then to go back in and time them out, right? So at this point, I'm going to arbitrarily put a keyframe every 10 frames, okay? The first sequence, the first pass, is just to throw down keyframes. That's all we're trying to do. We're trying to basically define the answer of what. What are we doing? And then we'll figure out when and how long in the second pass, okay? So I got one there on frame 1, okay? Let's fire off. So let's see. I think I want it to mechanically maybe rate in there. Well, let's give it, maybe it's going to go, let's see. Yeah, I'm going to have it go up in here. Go forward another 10 frames. So it went up, and now I want to have it go down. And I'm just going to kind of slalom through here. And I'm just, remember, if you look carefully here, oops, I apologize. Look how far I'm animating in my flying saucer left to right. If I did it like that, it wouldn't make sense visually inside the frame, okay? But in here, I may have to break reality a little bit. Then go to frame 40. Somewhere right around in there, I think. Frame 50, and then I think this is where I'm going to start saying goodbye. Oops, excuse me. Frame 30. I lost myself a little bit here. I apologize. Here we are on frame 30. Frame 30 needs to be out here a little bit more. 40. There. So it goes. Now we're just going to zip off like this. All right. Let's see how that works. Oops. There it is. Okay. That's a framework. It really is. Let's turn off my auto key so I don't mess anything up. And I'm off to the races. Now, I got some work in here that I need to do to continue to refine the timing of this, but now that we have some basic motion going on, we need to start bringing the dope sheet into the mix so we can start exploring the timing of all this. Because keep in mind, all of this was arbitrarily keyframed out just in 10 frame increments. That's not the final timing that I want to have, okay? I know that at the beginning here, I need to break reality and have my flying saucer move a little slow, okay? There are additional layers of detail that I want to add to this, like some banking and some rotation and what have you. I think just for time's sakes, I'm not going to have time to do that. I'll let you guys explore that during your lab. But now we need to bring in the magic of the dope sheet so I can get my timing, because if we were to play it back at frame rate, way too fast, especially right here at the beginning. Man, I can't even see that there's a flying saucer there, okay? When things are closer to camera, pop quiz, should they be moving fast or slow? Slow. It seems like it should be the opposite, right? It seems like we should make them move really fast, but when they're closer to the camera, we need to slow reality down very directly so the audience can see. When something's right in front of your face, you have to give your audience some time to digest that, especially when it's something like a flying saucer or something that's kind of unique, okay? You just can't show them, a couple frames of something and have them consume it correctly. So we got to slow down our movement here, okay? Things close to the camera equals slow movement, and then as they're further off in the distance, they can speed up, okay?
I think that's sort of like how most shots of ships in Star Wars are always slowed down.
You got it. You got it. I mean, if you think about it, if you go look at an X-Wing starfighter, right? These things are spaceships, so it's probably safe to say that they're flying hundreds of miles an hour, right? Well, even an airplane, hundreds of miles an hour to stay afloat, right? If we were, this is not to jump back onto the bag, and over in Moto, you can actually visualize the speed of stuff, right? And you can actually put, it would calculate the time, the distance travel and the time that it traveled within that distance, and it would figure out the velocity and all that. It was pretty neat, okay? And I was always amazed at how slow my objects were actually moving as they went by camera. I remember doing this an airplane once, and the airplane flew right by camera, and I think I had Moto calculating the speed, and I think it was going like 10 miles an hour or something like that. But remember, we're not trying to capture reality, we're trying to create our own, okay? So we have to break the illusion of speed to make it work inside the render camera. All right, so to the dope sheet. Windows, Animation Editor, Dope Sheet. Okay. Pop quiz from last week's conversation. What is the purpose of the Dope Sheet? Timing. Say again?
Keyframe editor?
Not Keyframe Editor, the Dope Sheet. So if you go into the Windows Animation Editor, Dopesheet. We'll talk about the graph editor in the future. Dopesheet. Next week is going to be all about the graph editor, by the way. Dopesheet. Okay.
I tried to move the frames using Dopesheet,
Mm-hmm.
and it worked as well.
All right. So how do we? So I got my flying saucer selected. This is for you. Okay. So you were having a hard time, excuse me, moving your frames around.
Yes, actually.
So that's a keyframe. The black dots are the keyframes in the Dopesheet.
So did you select flying?
Yep, the Dopesheet's only going to show you the objects that you have selected and the keyframes that are associated with that selected object. Okay, you get a nice list on the left-hand side that tells you what it is that you're working with. And you can actually break it down a little bit more directly too. So I have a pretty simple hierarchy in mind, so I don't get a tremendous amount of granularity, but it's there. Yeah, so here's all of our keyframes. You can even do it individually on a per channel basis, which is kind of neat. Okay, that's if I had the time to go in and do the banking, that's something that I absolutely would look to do. Or if you're rotating your object, the rotation keyframes are going to drag behind the translation keyframes to get the illusion that the weight is shifting. Okay. All right. But for now, what I'm going to do is that I'm just going to work with this as is, just with the overall representations. Okay. Now with the Dopesheet, moving the keyframes around is easy, right? How do I do it? Do I left mouse button and drag? Middle mouse click. Okay. It's the middle mouse button that allows you to, to drag it now. Why am I not? Translate. What's going on? Like I said, I'm going to take a cleansing breath today. Cleansing breath. Yes, sir?
So I do have a general question about the Dopesheet. Why you would just do the keyframes on the animation?
No. So remember our process, right? We established the animation, or we established the keyframes, right?
Yeah.
Your first pass on all of the keyframing is going to be wrong. You're going to need to edit the location of these keyframes in the timeline to adjust to your illusion of speed. That's the purpose of the Dopesheet. Yeah.
I'm moving my space server here, and I don't see it here.
Yeah.
Why?
I'm going to guess that this is probably your camera way up over here. It's probably behind your camera. Your spaceship's behind your camera. Orbit up a little bit and look down at your scene. Yeah, there's your camera.
Okay.
So your camera is facing that way. Orbit up a little bit, so you're kind of looking at the top of your scene. Well, that's what your camera's seeing, right? So in this viewport here, you're looking through that camera's viewfinder. Over here, the orbit up some. There you go. See, look, your spaceship is behind your camera. Keep going.
So, no, I still don't understand where it is.
Yeah, okay. Orbit around a little bit. Okay. Still behind it. And it's way up high. Keep going.
So, camera is looking this way.
Mm-hmm. There it is. Yep. All right. I got to figure out why I can't move my dope sheets. Ah, I know. Wait.
So now you're gonna wait.
Oh, this is driving me crazy. Is anyone else getting this dot? Why am I not be able to do it? What's wrong? What's different here? Yeah, I am. There it is. because I was in the wrong tool. I think I was in this one. I think I was trying to insert keys. Move nearest picked tool. There we go. Now it's working. Golly, that was driving me crazy for a second. Okay, now that we're up and running, let's get to work here because I got some work that I need to do. Okay, so I'm currently viewing my timeline on frame 37. FYI, the dope sheet inside of Maya doesn't allow you to advance easily your playhead, so it's definitely a window that's supposed to be open and it complements, if you will, the animation timeline downstairs. There's also some workspaces that will allow you to split your viewport to see the dope sheet on the bottom and then viewport to the top. Do whatever works, best for you. Okay, I like having floating windows. That's my style. Okay, so I'm just going to keep working like that. All right. So I know here at the beginning, I need to start spacing out my keyframes to get the illusion that I'm after. So I'm going to select a whole bunch of these things, and it's not going to work anymore. W. Go. That was my fault. I had a Moto keyboard shortcut error there. I apologize. No. What's going on? Oh, that's stupid. Okay, so I was zoomed out so far that I don't think Maya understood where I was trying to move those keys. And this is something that I had forgotten about, a nuance. So I have that first keyframe selected. See how I'm holding down the middle mouse button and I'm dragging and nothing is changing? That's frustrating, right? Then, exclusively, if I just simply zoom in so that the dope sheet, so I can see every single frame on the dope sheet, see how the ruler has changed. Same thing, middle mouse button, now I can drag it. Golly, that drives me crazy. It's little things like that. Okay, so what I'm going to do here is I want to middle mouse click. I got them all selected, so now I'm moving everything after that first group down some. And let's see, let's start planning out my timing here. How long do I want this first bit to be on frame? Let's play it back. Needs to be slower, so I need to space these out more. So this is really a process of going in. This is really a process of going in and spacing out.
Did you select all of them and move?
Yeah, I think I don't have, I'm only moving them at once at the moment, so I'm just going to keep going with that, and then we'll work on that during lab. So you got to move, make an edit. Oops. Got to make an edit and then play it back. There we go. It really is something, make an edit, that's pretty good. And then once it gets to that second set, I need to start working this as well. Okay. Don't try to make this go faster than it needs to. This is a slow process. Let's see. I think if I remember correctly, it's one of these. Frame Alderson, playback range. Okay. All right, let's see how it looks now. That actually kind of works pretty well. I'm liking that. I got some work there in the middle that I need to fix. But as a whole, this is a good set of keyframes. Okay. Let me go find the area that's a little too fast. So that keyframe to that one. So the set on frame 43. That one. Let's start spacing these out. Now, I'm not looking at frame numbers here. what I'm doing is that I'm just trying to do this visually, okay? I make some changes. Yeah, that's good. I like that. And then play it back. Don't get bogged down in numbers. This is not science. Don't make it into a science. No, not spaceships. Animation. Yeah, I actually like that. I think I'm kind of digging that. That's kind of that's close enough for my little in-class demonstration, which admittedly is like watching paint dry. It's not entertaining at all. Okay, so this is starting to work pretty well. So we keyframe our animation. Okay, and you can literally put all these keyframes on, 1, 2, 3, 4. It does not matter initially. Okay. Animation is an art form of many passes. We want to give ourselves an opportunity to establish the what by establishing these keyframes. Then we go back in another pass and start establishing the when. We start moving these keyframes out and getting the illusion of speed that we're going for here. Okay? Do yourself a service and don't try to do all of this in one sitting. Go through the passes. Okay? Keyframe pass, Dopesheet pass, and next week we'll talk about the graph editor pass. Okay? Each of these passes are designed to give you an edit point that will hopefully produce more granularity for your movements and finer quality movements. Okay? I'm pretty happy with what I've created here. It's not good, but it's good enough for our little in-class demonstration. And now what I want to do is I want to get this animation out of Maya. Okay? I want to be able to get it out of our timeline. Sometimes if you have really complex scenes with a lot of deformers or maybe even some sort of simulated rigid body or soft body dynamics, the playback inside of our viewports can be really, really poor. So at times we just need to get it out of Maya and into like a QuickTime format that allows us to see what our shot's going to be separate from the performance of Maya. This is called a play blast. And play blasts are a great simple way for us to hand around our animations without actually having to physically hand around the Maya project file. Okay? And they're really easy to create. The only thing that we need to be mindful of is the viewport that we have selected. Now, I know that I have this viewport selected. What tells me that I know that? Interface-wise, it's this little gray boundary. Okay? Let me move my cursor a little bit so that I can select the other one. This is the other viewport. See how that gray boundary changes? The viewport that has the gray boundary is described as the active viewport. Okay? The play blast is only going to be created from that active viewport. So I want to have this viewport, my render camera viewport, be active. And we simply do this by going to the top of the screen and it's under the Windows pull-down menu. And it's right down here, down at the bottom. Play blast. Okay? This is a Maya made-up word. If you're a software developer, you get to make up stuff. Okay? It's pretty cool to make up words that are now part of the English language, like play blast. It means nothing. Okay? There are some options that you should be aware of. Okay? Like, for example, do you want to do start to end of your entire sequence or just the time slider? Now, my animation's pretty short, so I'm just going to do, let's see, I'm just going to do 80 frames.
Where's the play blast again?
So it's under the Windows pull-down menu, right there. Okay. Okay, show ornaments. This is going to be all of the on-screen badges and what have you, like the compass, the action handles if the tool's going. So I'm going to turn that off. We don't need this. Okay. Multi-camera output. I'm not sure. Yeah, actually I do know what that is, but that's pretty advanced. And then this is the format. You know, you can probably just leave this as is. This is not supposed to be a replacement of a full-blown Arnold render. This is like a preview, right? It's just to get it out of Maya and see if it's working, okay? To send it over to your sequence supervisor and say, hey, is this kind of working the way I want it to work? You give it to the director and say, hey, is this working before I really start making it awesome, right? Okay, and of course we want to save it. Let's give it a good name. I'll just put this shot 01.
But is it render camera or it's perspective?
Yeah, it's whatever viewport that you have selected. Yeah. Play blast. See how I did it real quick? Just takes like 10 seconds to do it, right? And then there's the quality of it. It's pretty low quality. And we're on our way. Okay. The purpose of the play blast is what? Preview. Where? Outside of Maya, right? This is now into an image or movie format that we can send to any place on the face of the planet. It will open. Okay. You don't want to give your Maya project file to people that don't know Maya. That is dangerous. Yeah.
Would this only be relevant when you can't play it back in real time?
Absolutely, for sure. Yeah. If you can't play it back in real time, make a play blast real fast. That way you can at the very least get a good sense of how it's working.
Would you do a play blast even otherwise?
I do play blasts all the time. Yeah. Just to make sure that what I've created is playing back at the correct frame rate, that my system is not influencing or that this instance of Maya is not influencing my understanding of what it is that I've created. I send this to clients and team members all the time. Just a quick little, here's my animation, see if it's working type thing. Arnold renders take a long time. That took me exactly 10 seconds to make. This is a great way just to kind of keep the ball moving without actually physically having to generate, a full-blown render. All right, so here's what I want you guys to continue to do. I can see that a number of you guys are working away on your lab. I want you to go ahead and continue to finish this, okay? When you're done, I want you to make a play blast of your animation. So you're not going to do a render of it, right? Just want you to make a play blast. A lot of our lab assignments, things that we do in class, hey, Levi, just 1 second, okay? A lot of the things that we do in class during lab, we're just going to do play blasts for, right? We don't need to do a full-blown render every single time. Homework is often going to be a full-blown big render, okay? But our play blasts are easy ways just to get it out and into a format that we can see across the web, okay? So make a play blast for this animation when you're done. Here are the particulars that I would like you to include. Make sure you're using arcs, okay? Do some banking and rolling of the flying saucer as it's going through the little slalom course. Try to recreate the illusion of flight with this little object, okay? Make sure that it's on the dot, 240 frames, okay? On the dot, no longer, no shorter. So plan your entire animation around that duration. If your animation is 90 frames and then it's nothing for 200 or 150 frames, fail. Okay, so your animation needs to take 240 frames. Use that container as a playground, okay? And then, most importantly, make it epic, make it awesome, have some fun with this. This is supposed to be a fun little animation to kind of continue our exposure to the world of object level animation. When you're finished with this little lab assignment, and you're going to have some time in class today to work on it, you probably will be able to get a bulk of it done. Make sure that you're submitting both the Maya project file and your play blast to the assignment sheet on Canvas. Sound good? Everyone understanding what it is that we're trying to do? All right, so it is 2:51. Please make sure you take a break, and then we will talk again probably right around 3:30ish. Sound good? Let's get to work.